So let's say we have a graph, and on the x-axis is your time in seconds, and your y-axis is your position in meters from a specific point, from your starting point. Let's say you're just walking down a path, and you sketch this graph from your starting point. So at 2 seconds, you're 4 meters away, at 4 seconds, you're 8 meters away, and so on. Now, what would happen if we tried to draw the derivative of this graph? Well, it would look like this. It would look like this, just because it's a straight line. Because this is linear, the derivative would be a straight line. So that's d over dx that we did. And this, its x, is also t in seconds. But the y-axis is its velocity in meters per second. Because it's a derivative of this graph. It's how this graph is changing. How your position changes is velocity. Now let's say we wanted to know how far you traveled between 2 and 4 seconds. Between your trek while you were walking, how far did you travel in this interval? Well, we know that distance equals velocity times time. And we have that right here. The y is velocity and the x is time. So we can just multiply this box and we get how far we traveled in this interval. So our velocity right here is 2. This is a height of 2 and a length of 2. So 2 times 2 is 4, so we traveled 4 meters in this. That's the area of this rectangle, and so that's the area we traveled in this interval. Now, how can we relate this back to our original function? Between the intervals 2 and 4. Well, if you notice, if you just take their y values, just go to the left, you see their y values, 8 and 4. What's 8 minus 4? That's 4, our original answer. So what have we observed? Well, if we have two intervals and we want to find the area underneath, we can just go to the antiderivative and go and find the difference between these two x intervals at that function. Let's try to find another point. So let's see the distance between how far you traveled between 5 seconds and 7 seconds. Now, in this area right here, from this graph, we know that it's just 2 times 2, sorry, because this is a different scale. So 2 times 2, that's 4. So we know we've traveled 4 meters between 5 and 7. And from this, from the intervals 5 to 7, we look on their y values and we find the difference. The difference of 14 minus 10 is 4. This is a fundamental theorem of calculus, where to find the integral of any function of, let's write out this, our first example. So that's just the integral between 2 and 4 of this function. What's this function? Well, this function is just this stationary point at x equals 2. So our function is 2. And that's dx. So, how do you find the area of a definite integral? You find the antiderivative. Why do we find the antiderivative? Because if we find the antiderivative, we can just look at the y values and find the difference. So the antiderivative of 2 is just 2x, and we find that at 4 and 2. And so we just do the regular thing for definite integrals. 2 times 4 minus 2 times 2. This will just equal 8 minus 4, now equal 4 meters. That's why you have to take the antiderivative to find the integral.